Hi, Steve here from SB Science Tutoring. I just thought I'd do a little video for you today to build on what I did a few weeks ago. One of the big things I'm a fan of is how science education can help you think critically and help you analyse the world around you. To do that, we do need to dig into a little bit of philosophy of science, I guess, and data handling and philosophy of data handling. We call that statistics, but the way we think about data is extremely important. The thing that inspired the original video was the linking of autism and autistic spectrum disorders being spuriously linked with the use of Tylenol, or paracetamol as we call it in this country, in the US. It was curious to me how the people in charge were able to make a broad sweeping public statement from their position of power, and how they felt so sure about what they were looking at. I think it's highly important that you know as an individual how to kind of assess data and how to look at these two things. The two things I'm going to talk about today: correlation and causation, and the fact that they are two very, very different things. So to help me do that, what I've done is I've looked at some data. Now, okay, you got me. It's not real data, and I'm sure there'll be people who in the comments will write that I've used the wrong form of graphical representation for this data. Do you know what? I'll take that on the chin. The reason I'm doing it is because it's just a bit easier to see the correlation and the trend in the data that I'm showing you. Okay, so here's what I've got. Okay, I've drawn you a nice graph. Okay, I'm a science teacher. I love graphs. I'm all about the graphs. And on here, on our y-axis, I've got a mount. I haven't really put a scale. Like I said, it's data that I'm assuming exists somewhere. Down here, I've got the month of the year. Okay, and it starts at January, ends in December. Okay, somewhere in the middle here, we'll have like June, July and August, okay? Now, this first line is sales of ice cream. If you look at it, not much ice cream is sold in January and December, but there is loads sold in the summer, unsurprisingly. The second line represents the amount of people who get sunburned. Now, let's have a little look at that data, all right? The two lines are extremely similar. The data sets move and increase in a very, very similar way. So what we have here is a direct correlation. There's a pattern in each set of data which moves in the same way. It increases in the same way. I would call this a positive correlation. The trend in the data is the same, and it's a rising trend. It follows itself point for point almost. That's what we're getting here. Okay, now a correlation is just a pattern in data sets and between data sets. However, looking at this, it would be very easy to make the statement that ice cream causes sunburn. Let's have a little look at it. In the middle of the year, in the summer months, we sell the most ice cream, and that's when the most people get sunburn. Is that true? We know it's not. We know it's not. So correlation is not causation. In order to establish the cause of sunburn, or indeed the cause of increased sales of ice cream, we need to do further investigation. Quite often in science, that's where the experimental design comes in. That's where we start to talk about designing an investigation to look at how those two variables interact. That's where you would plan your little experiment. So correlation is a pattern in data sets. Sometimes that pattern agrees And it does cause us to assign this thing called causation. We can sort of come up with a false idea of one thing causing the other. And it's not always the case. In order to prove causation, you need to do further investigation. And that further investigation has to be data-led and evidence-led and observation-led. Causation can be easily inferred from correlation, but sometimes it's just not the case. Now, there is another problem here. Human beings are looking for patterns. It's called confirmation bias. And we do tend to fall into this trap of assigning false causation when we see a pattern. The way we live our lives today reinforces that. The irony isn't lost on me that I'm making a short YouTube reel about correlation, causation, and a little bit of confirmation bias, because I'm now going to go on to tell you that the way we consume information quite often acts as a magnifier for our confirmation bias. Another thing for you to be aware of. I said this in the last video, I think. Actually, our phone is limiting the range of things that we get. We tend to find information that is in agreement with our existing worldview. So it narrows our experience of the world. That makes us assigning false causation a lot more probable. So let's think about this. Try and look at other sources of information. Use that to help you run down the cause of something. And if not, design an experiment to find out. Anyway, if you like this little bit of a delve down into the rabbit hole of the philosophy of science and the use of data and how science education allows you to think critically, please like and subscribe. It's important to me that I can get some of these ideas off the ground, and you'll help me a lot by doing that. Until next time, stay curious about what's going on out there. Make sure you're looking at everything around you and you're thinking critically about it. And I'll make another one of these next month.